All right, so like I said, we're on 4.8, and this is basically modeling combined functions. So basically what you're doing for all of these, on your homework as well, is you are adding, subtracting, multiplying, and dividing functions. You're creating a function based upon the information they give you, and then you're combining them in some form or another, okay? And they're pretty straightforward what they are. But here we go, like Josue saved $6,000 to invest towards his retirement. Okay, so Josue saved $6,000. He plans to split it between a more conservative retirement account that earns 6% annually and a more riskier stock that could return 12% annually. So some of it's in an IRA, some of it's in a stock market. If X represents the amount in the riskier account, okay, so X is how much he puts in the riskier account, write one function for the conservative estimate, conservative investment, and one function for the riskier. Okay, so you got two things going on. You have, he's splitting his money. Some of it's going into a risky option, we can make a lot of money on it, but it might do bad, and he has got one that's a lot more conservative. He's more likely to make good money, but not as much. You follow just how investments work. So here we go. For the risky, so for the riskier one, R of X. Well, what percentage does he make on the riskier amount? Does he make the 6% or the 12%? Is he right? It's the 12. The riskier stock that could earn 12% annually. All right, so 12%. How do you use 12% in an equation? Is it 0.012 or just 0.12? 0.12. You only got to move it twice. So 0.12x, because x is how much you put in the riskier account. Okay? Your more conservative one. All right, the not as so risky. What's the percentage on that one? 6%. Is it 0.6 or 0.06? 0.06. You got to move it twice. So, would it be just like that? Because X represents the amount in the riskier account. So is X the right thing to put there? Actually, it's not. This one's a little bit of a tricky one, but here's the deal. It is 6,000 minus X. Because if he's doing $6,000 total, all right, 6,000 minus whatever he puts into this one, all right, is how much you'll put into that one, right? Does that make sense? That's what's going on with this. This is just, hey, however much total minus whatever you put in there is what he's putting in here. All right? And from here, you just need to distribute. So distribute it out. What is 0.06 times 6,000? Anybody got a calculator? Or cell phone or whatever. We're distributing. What is 0.06 times 6,000? 360, so 360. And what is 0.06 times -1? Good. All right. So that is his C of X. Okay, so the second one was a little trickier, but it had the same idea to it. Okay, you just had to know how much money he was going to make. Cool. Any questions so far? All right, next question. This is when we start doing things with it. It says, write a function to model the total interest he would make on both accounts together. All right, so, well, if that's the risky and that's the conservative, what would you do to those two to find the total amount he makes? Add them together, exactly. So, R of X plus C of X. Well, R of X is 0.12x, and C of X is 360 minus 0.06x. So your total is, start combining. How many x's do you have? 2. Add them together, though. How many do you have? It is a negative. It's not 0.6, it's 0.06, because 0.12 minus 0.06 is straight up 0.06. It is a coincidence that they are the same thing. It is. It just happened to be that way. You're right. And then we got the plus 360. So that would be the total amount of interest he's expecting to make. Cool? So in this case, we had to add them. Okay, the next one. It says, write a function to model how much more riskier investment will earn. How much more will this one earn compared with the more conservative? Well, if you want to know how much more one is than the other, what do you do to them? You subtract them. If you're 6 foot and he's 5 foot, to see what the difference is, you subtract them. So your d of x is your risky minus your conservative. Cool. So here we go. Your risky one is still 0.12x minus your conservative 360 minus 0.06. All right. All right, what do you got to do to those two?
Distribute the negative.
Okay, so we'll distribute the negative. That's a good move.
So you end up with negative 360 plus 0.06.
Good. We got a negative 360 and a positive 0.06x. All right, so combine your terms. I got just enough room to put this up there. When you add your x's together, how much do you have? What's 12 plus 6? So 0.18x. And can you combine the 360 with anything? No, so just bring it down. Cool. How are we doing with this so far? Give me 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. Sweet. All right, this last one is the difference, right? That's the difference between the two, how much more one is the other. The question, here we go. How much should Josue invest in the riskier account if he wants to earn 10% overall? How much more if he wants to earn 10% overall? Well, okay, so he wants to earn 10% of $6,000. All right, and which function was the overall, both of them together? R, C, T, or D? Which one was both of them together? T. So we'll take 0.06x plus 360. All right, this is how much he's wanting to earn, 10% of the 6,000. This is how much they make together. Does that make sense? So here we go. Start cleaning it up. What can we do to clean this up a little bit?
Multiply 0.1 times 6,000.
Okay, so what's 0.1 times 6,000? 600.
Are we trying to get the x, y, z?
Yep, we're solving for x.
So
Subtract 360, so minus 360 to cancel out that puppy. So what's 600? What's 30? What's 60 minus 36? 240. So 24. Oh.
and then left and least divide 0.6 or 0.06.
Just pull out your calculator. Why'd I gotta sound like an Aussie when I do that? Pull out your calculator. So 240 divided by 0.06.
Okay, I got 4,000, is that right?
That's right. Is it 4,000 even?
Yes.
Wow. I was not expecting that. There you go. That's how much money he should put in the riskier account if he wants to earn 10%. So if he puts 4,000 in the riskier account, how much is he putting in the more conservative account? 2,000, right? Because it's 6,000 total. All right. That's kind of the follow-up questions to that. So this is how they all work, okay? They say, hey, build these two equations. Well, sometimes they're pretty easy, sometimes they're a little more difficult. And then it's like, hey, in this situation, what are you going to do? Well, you add them. In this situation, what are you going to do? Oh, you divide them, that sort of thing. All right? Let's keep going. Let's turn the page. All right, this one's a little more challenging, but not by a whole lot. It's just because we're dealing with circles, and people freak out when we deal with circles because we have that ever so elusive pi. Don't let pi freak you out. Please don't. It's just like an x in a lot of ways. Means we have two of them. All right, so here we go. A woodworker makes a two-toned table where the inner circle of maple costs $4.19 a square foot. So this one is $4.19 a square foot. All right, and the outer ring of black walnut is $5.31. So I'm going to go ahead and label those real quick. So this is walnut. This one is maple. Okay? If x represents the radius of the maple, okay, so x is the radius of the maple, write a function to model the price of the maple. Okay, so we want the price of the maple. Okay, so here we go. For your x, well, let's see, we got to find the area of this guy. How do you find the area of a circle? What is the equation for that?
So if you have the radius, it's 2 pi r.
That's the circumference. It's pi r squared. Okay, so if that's the area, it's the area times the price. Okay, so if you want to know the price of it per square foot, it's the price times the area. So m of x equals, what's the price for that one, for the maple? $4.19 times its area, which is pi. In this case, r, what's the r in this case? It's just the x. It is just the x. Because we don't know quite what it is, we just know that it's an x. So that's the price of the maple. Cool. Write a function w to model the price of the walnut. Okay, so here comes the fun one. So the walnut, is it the entire circle or is it just the outside ring? It's just the outside ring. So to find it, you got to take the area of the outside and do what with the area of the inside? Subtract it. Okay? So the walnut equals the price times the area of the outside minus the area of the inside. Now, these variables I'm throwing up there right now, they don't necessarily have to be that. I'm just saying this is the semantics of what I am doing so I can start plugging things in. Does that make sense? That's all I'm doing with that. So here we go. What's the price for the walnut? $5.31 per square foot. All right. The area of the outside, well, that's pi r squared. Well, what is the radius of the outer circle? How many x's are there in that radius? 2 of them. So it is simply 2 what? Just 2x squared. Okay, because it's 1x plus another x, which is 2 x's. Minus the area of the end circle, which we already decided that one was just pi x squared. Cool? All right, let's clean that up a little bit. What can you do to clean this up? Multiply that on what? Okay, we can distribute the 5.31. So let's take care of this as well. What's 2 times 2? 4. So what's 4 times 531? Mr. Hunter's wife is not in that world. Hey, Michael, did you take your physics test with you? Check your bag. She's saying you got it in your backpack. Miss Lee wants to see you either way. All right. Take your bag with you. I love it when I do something stupid like that, and people just kind of go on like nothing happened. Oh, and I was still recording that. Oh well, they get to have fun with it. All right, so here we go. So here we go. We got that 2 squared, which is 4, and 4 times 531. Have y'all got that one yet? 2124. So 21.24 x squared, or pi x squared. Sorry, I forgot my pi. How could you forget pi? All right, and what's, well, there's a 1 right there. So what's 531 times 1? 531 minus $5.31 pi x squared. There's one more thing you can do to that. Good. These are both pi x squareds. So add their coefficients. What's 2124 minus 531? 1593. $15.93 times pi times whatever the inner radius is squared. That is your total cost of raw materials. Cool? All right, so this one was a little more involved. All right, because you had to find out what the area of that outside piece was. All right, but that was the hard part. All right, after that is. Let's go. Write a function to model the total cost of the table's raw materials. Okay. Well, if this is the price of the outside, and that's the price of the inside, what do you do to find the total? Is he right? I'm seeing some nods. I'm seeing some nods. Come on. If you want to find the total amount, what are you going to do? You're going to add them. So we want the maple. I know this is like riveting stuff. Groundbreaking. So we got $4.19 pi x squared for the first one, and what is it? 1593? 15.93 pi x squared for the other one. So add them up. What's 519 plus 1593? It's like $20.12, something like that. 2012. A year long past. Where were you in 2012?
Oh, eating.
Probably eating. That was what, 6 years ago? So if you're a junior, you were in 7th grade. If you were a senior, you were in 8th grade? No, that can't be right. If you're a senior, you were in 8th grade. If you're a junior, you're in 6th grade. Whatever. All right, last but not least, what is the total cost of a table that has an inner radius of 18 inches? Inner radius of 18 inches. Okay, so what are we going to do with that 18? Plug it into the X. Almost. The question I have here is your price. Your price is in square what? Square feet. Square feet. So how many feet is 18 inches? Anybody know? 1.5. 18 inches is 1.5 feet. 12 inches in a foot, 18 in a foot and a half. So here we go. We want to know what 20.12 pi times 1.5 squared is. So take out a calculator. What's 1.5 squared? 3. That's that's times 2. 1.5 squared is not 3. I guarantee it. So what, $2.25, I think? $2.25. All right, what's that times 2012? Just multiply it across. 225 times 2012 is 49. All right, multiply it by the pi. Let's get the total price. This is where you start getting funky decimals. $142.21, so 22 cents because it's a 9. That is the price of the wood in that table. And that actually, believe it or not, it's actually kind of reasonable. Cool. All right, here we go. Let's do the next page. I'm going to skip that question. I think y'all can pull that off. All right, this one is about as hard as it gets. It's just mathematically a little complicated, but the idea is the same. All right, an architect is designing rectangular pillars with square bases. Okay? To model the volume of the pillar, he uses this function, v of x equals all of that, where x is measured in feet. He uses h of x for the height. So your height is x plus 4. I'm going to go ahead and write that in so I know it for later. Okay? So first things first, write a function a to represent the area of the base. Okay, write a function a to make area of the base. Well, we know the volume, and we know the volume is the area of the base times the height. That's just the volume of a square pyramid. Square whatever. Rectangular pillar. So what are you going to do to find a? What do you got to do to solve for a in that case? Divide by what? H. Very good. So it's my volume, which is x plus 4 times 4x squared plus 12x plus 9 divided by your height, which in this case, what's your height? X plus 4. Let me clean this up. That really should read a of x. All right? Cancel out what? Good. So the area of your base is good. Ax squared. The ax is 4x squared plus 12x plus 9. That is the area of your base. So in this case, we had to divide. They gave us the equations. We just had to divide them. All right? Write a function p to represent the perimeter of the pillar's square base. Okay, so how does the perimeter relate to the area of something? How do you find the area of a base? How do you find the area of a square? Base times height, or length times width, however you want to do that. Okay, so the area of a square is base times height. Okay, what's the nice thing about a square? Well, but concerning the base and the height, what do you know about the base and the height of a square? They're even, they're the same, right? So it's the same thing twice. We're looking for what times itself is going to equal that area. Okay, so the area is 4x squared plus 12x plus 9. So let's factor it. See what you get. I do this one specifically because there's one like this on your homework. Okay? So let's start this one out. What are two things that multiply to the left? 2 and 2. Okay, so let's try that one. What are two things that multiply to the right? 3 and 3. Are those the same? Yeah, okay, so that has the possibility of being the sides of our square because they're the same. So let's check it out. What's 2 times 3? 3 times 2. Do those add up to the middle term? Yes! So those are the length of your sides. They're the same, and they multiply up to the area. So I'm going to go over here real quick and go 2x plus 3 and 2x plus 3's. So the original question asked for the perimeter. Well, how many of those 2x plus 3's do you need for the perimeter? 4, right? So the perimeter equals 4 times 2x plus 3. Cool. So distribute it out. What's 4 times 2?
80.
What's 4 times 3?
12.
That's the perimeter of your base. All right, now so this one was a little trickier because you needed the perimeter of the base, not the whole thing, just the base, and all they gave you was the area. And so you kind of had to backtrack back down to the sides. All right, last question. We'll call it a day, I promise. Cool? And we'll do the last one tomorrow. Write a function s of x to represent the surface area of the pillar. Well, this one you just straight up need an equation for. The surface area of any rectangular prism, is the area of the base. How many of those bases do you need for a surface area? One on the bottom and one on the top, so you need 2 of them. So you need 2 of those. Plus the perimeter of the base times the height. Okay, so that's the equation you need, and you don't need to build that. That's just straight up what it is. All right, it's twice the area of the base plus the perimeter of the base times the height, which we have all of those. So s of x equals twice the area of the base, 4x squared plus 12x plus 9, plus the perimeter, which we said that was what, 8x plus 12? No. Yeah, 8x plus 12. Times the height, which, do you remember what the height is? X plus 4. So start multiplying. All right? You want me to zoom in or zoom out? Oh, that part up top? I'll do that in a minute. Let's do this. Oh, like that. I see what you're saying. All right, so here we go. What is 2 times 4? So 8x squared. What is 2 times 12? So 24x. Come on, keep writing. What? Oh, 24x. What is 2 times 9? 18. The sound effects make it all worth it, and you know it. All right, so let's go over here. What is 8x times x? Good. What is 8x times 4? 32x. All right, so that was the 8. So let's move over to the 12, last piece. What is 12 times x? And what is 12 times 4? Good. So let's combine them all. I'll change colors back. I got an 8x squared here and an 8x squared there. So how many x squareds do we have? 16. All right, I got a 24, I got a 32, and I got a 12. Add them up. What do you get? 3, 4, 5, 6. So 68? Cool. Plus 68x. All right, and I got 18 and I got 48. So that is, I think, 66. Is that it? Yeah. All right, cool. 66. So your surface area equals that. Cool. So with ones like this, you got to start off with a formula you know. All right, and if you got to look it up, you got to look it up. That's what it is. But that's the surface area. And then you plug in all the pieces. I know the area of the base. I know the perimeter of the base. And I knew the height of the base. And we just plug them all in, multiplied what we need to, added what we need to. Cool? All right, we're going to call it. We'll finish this up tomorrow. No.